Baby Shawties, welcome to our second video lesson on static electricity. There's going to be a lot of meat and potatoes in this lesson. We're going to focus now on the details of how objects acquire charge. So in 6.1 we looked at the whole idea of how charge is all due to the structure of the atom, and that it's all about the balance or imbalance of protons and electrons. That in a negatively charged object, that it's more so the object has an excess of electrons. If it's a positively charged object, that means it has a lack of electrons, meaning it has an excess of protons. And if an object is neutral, which again most objects in nature tend to be, or seek out neutrality, means that there's a balance of electrons and protons. And lastly, that if we wanted to quantify the amount of charge, it's just simply knowing that the charge of one electron is that special 1.6 times 10 to the negative 19th. And then we can find the charge by just multiplying how many electrons or protons we have. What we're going to do today is actually going to get a little bit deeper into how objects acquire charge. So we're going to talk about the different methods of how something can acquire a charge. What it's all based upon is something you guys analyze in the lab, is what's called the basic law of electrostatics. And this is what really governs all of electricity. And it simply states, and you guys have probably heard this before, that like charges, so positive to positive, negative to negative, so like charges, so positive to positive, negative to negative, that those types of charges tend to repel each other. And if I have opposite charges, like positive to negative, those types of charges are going to tend to, whoopsie daisies, not opposite, but those would tend to attract each other. This is what's known as the basic law of electrostatics. So like charges will repel and opposite charges will attract. And this is really, like I said, what governs all of electricity, because this is what's going to cause an object to become different types of charges. So what we're going to do today is we're going to apply this basic law of electrostatics into the different ways things can acquire charge. Now, when we go through this, obviously it's some of the materials we're using in our labs that we're doing in class. You saw us using like the black plastic rod with fur, the glass rod with the plastic bag. We had the pith ball that was coated in metallic paint. We did some stuff with the aluminum soda cans. So there's different types of materials that we can use, and it really breaks down into two types. Just kind of like the extremes, because there are some ones that are kind of in between. But we have, first of all, what's called conductors. So in electricity, the main type of material we're going to use, especially when we get into current electricity, is a conductor. And a conductor is things like metal, water, you can see here like copper, different things like that. What's so important about a conductor is that it's going to allow the flow of electrons. And why is because of the type of bonding, type of material they're made out of, that they allow electrons to flow freely from end to end. So if I bring, for example, a charged object near a soda can, when you did that little simulation, you would see that the electrons would move within the soda can. Because it's made out of metal, the electrons have the ability to move. Versus the opposite, an object that's an insulator. Insulator, things like rubber, glass, wood, those are things that don't allow the movement of electrons. Not saying that those objects cannot acquire electrons. The thing is that when they do acquire electrons, those electrons are stuck like glue to where they're put. So why we're using a glass rod and a plastic rod is that when we rub them with the fur, that charge that they gain from the fur stays at the point where we were rubbing them together. Okay, so we're using like the pointed end of the black rod. That is where the electrons would stay, and they would not flow freely to my hand. So why it's important is that when we look at like conductors, if we allow electrons to flow, if I have an excess of electrons that don't want to be near each other, again, they want to repel, electrons will move freely through that material to get as far away from each other as possible. If they're placed, like an excess of electrons are placed on an insulator, those electrons are stuck and they cannot move. It's like they're stuck in a quagmire and cannot move away from each other. So that's the big difference in why we use those materials. So first of all, just kind of understanding, this first example, we're going to look at what goes on in terms of how charge interact with each other. So this is the idea of the basic law of electrostatics, that like charges tend to repel, opposite charges tend to attract. So in case when we have four objects, we have objects A and B, and then C and B, so three objects, and what I want to know is basically what is the charge on each of these. So what we're given is we know that B is a negative charge. Okay, so B is negative. I'll show that here as blue. So we know that B is negative. Okay, so first of all, I see that B and C repel each other. So if I see that B and C repel, what I know automatically is that if they repel, that those two objects have to be the same charge. So I know right away that C also has to be a negative charge. Okay, now we look at A and we're trying to figure out what A is. A is attracting to B, and if B is negative, first of all, if they're attracting, I know that A could be positive. But here's the other key thing. There is a third, I guess, type of charge, which is called neutral. And what we talked about is as long as something is a conductor, like the pith ball we're using, or that soda can, if we have a neutral object that allows the flow of electrons, that a neutral object can be attracted to a charged object. So in A, I am not absolutely sure if A is just positive. A could also be neutral in charge, okay? So it could be positive or neutral because attraction could occur between either one of those. All right, so I want you guys to do this one. Case 2, try this one on your own. You are told here that object B, again, is going to be negative. So based upon that, I want you to try and figure out what A and C would be. All right, here we go. So A is positive and C is positive. Now, the reason why, if you look at this case in terms of the other one, again, what I said before is that A could be positive or neutral. But since I see on the other side now, instead of B repelling A, now that I see B repelling C, now I see A is repelling C, I know now that they have the same charge. So again, that means that A has to have a charge on it. So I essentially can eliminate it being neutral. I know right away it's positive, which again, since it's attracting B and I know B is negative, that those two things would work out. So again, like charges repel, opposite charges will attract, and then neutral objects will always be attracted to a charged object, which is why the more sure test to know if something has a charge and what the charge is repulsion. All right, second example is just looking at the difference between a conductor and insulator. Pretty simple example here. So based on sphere A and sphere B, which one of these is going to be an insulator, which one's going to be a conductor? So again, conductors allow the movement of electrons, insulators do not. Now, electrons are like charges. So for example, if I have, let's say, two small electrons near each other. So I have an electron here and an electron here. Since they are like charges, they want to get away from each other. They do not like each other, so they're going to repel. So anytime I place electrons near each other, they're going to try and get as far away as possible. But obviously they're restricted to the surface they're on. So here it's put on a sphere, okay, and both objects put on a sphere. Notice in A, all those electrons are clumped together. Electrons do not want to be clumped together, same here and same here. And B, the electrons are spread out along the outside. So the difference here is that A is going to be an insulator because the electrons are lumped together and cannot move, and B is going to be a conductor because those electrons have spread to the outer surface, which is as far as they can go. Okay, so now what we're going to dive into is how objects actually acquire charge. So you're going to learn about 5 different methods that objects can acquire charge. Some of them are going to be maybe temporary charges. Some of them are going to be permanent, kind of permanent charges, not they're going to last forever, but the permanent meaning that they're going to hold on to that charge. And some of these are going to be a kind of a combination of what goes on. So the main detail, and this has to deal with the whole conductor, insulator, and the basic law of electrostatics. The very first one we're going to talk about is polarization. Polarization, or to polarize something, means that you're going to make it into two extreme opposites. Okay, so in terms of charges, the extreme opposites are positive and negative. So this occurs when you bring a charged object near a conductor. Okay, so if it's near a soda can, near those pith balls that we're using, what happens is that when you bring an object near, the charges within the object, the conductor, are going to flow based on the charge that's brought near. And essentially what's going to happen is charges are going to be collected on one side, and the charge on the other side is going to be what's remaining. Key thing here is that anytime we look at the flow of charge, it's always about electrons. So say I take a neutral soda can here, and I bring a negatively charged balloon near it. Okay, since it's negatively charged, I know that electrons, and again, it's all about the flow of electrons. Electrons do not want to be near something negative because like charges repel, so negatives will repel negatives. So what ends up happening is that the electrons are going to flow from the left side of the can to the right side of the can. And as long as I hold that charge there, what happens is all the electrons are going to gather as far away as possible from that charged object. They're going to get away from the charged object, and they're going to spread out to get away from each other. But what that does is it leaves on the other end, it's going to leave all the positive charges. Now, the key thing here is that the positive charges do not move. So I'm not going to see positive charges moving. That is not a thing because protons do not move. But instead, the electrons leave, leaving positives behind. And this is called polarized because one end remains positive and one end remains negative. And this is exactly what happens in the soda can demo and in the pith balls, that we get two polar opposites, which causes then that the left side of the can in this case to be attracted to that negative balloon. Okay, and if allowed to, the can would move towards the balloon. So this is what's called polarization, when the flow of electrons create polar opposite ends of an object. Okay, now the second type of charging that we did was what's called triboelectric charging. Now this is the one, think about this as charging through friction, if you will. So this is what happens when we do in class. This is what happened when we had the rod and fur, and what happened when we had these, when we had the glass and the plastic or the silk, okay? So this is what was going on there. Triboelectric charging has to deal with something, again, it's when we rub two things together, but it deals with a property called electron affinity. That when we rub two different objects together, one of those objects is willing to take on electrons. And this has to deal more so with the type of material, and also gets into a little bit of chemistry with something called valence electrons. Okay, so valence electrons are the electrons on the outer shell of an atom, and sometimes atoms, if they're neutral, have empty space in that valence shell, that outer shell. So if they do, they're allowed to take on more electrons without really affecting the overall atom. Okay, so in that the case, some objects will take on electrons, but sometimes objects will not. Sometimes their valence outer shell will be full, meaning they won't take on electrons, but since it's full, they're willing to give electrons up. So what you get are basically two dissimilar, not objects that are not the same. One is willing to take on electrons, one is willing to give up electrons, okay? And this is all based upon what's called electron affinity. So it all depends on the different types of objects. And we'll look at in class the different types of objects, and we'll look at how we can categorize them based on their electron affinity. All right. Next two ones are going to be kind of the confusing ones. These are the big dogs. So throughout the labs we've done, we've brought objects near and made contact, especially with the pith ball. I had you guys do labs where we brought the charged objects near, then make contact and all that. And what you should have seen is, like, no matter what, when you bring an object near, you're going to see that force of attraction. But once we make contact, all of a sudden you'll see that pith ball would start to repel. So this charging by contact is what's called conduction. And again, charging by contact through conduction is going to have to make use of some sort of conductor. So we're going to allow the flow of electrons. But what happens is when I bring a charged object near, okay, so I'll bring, let's say, a negative charged object near, what's going to happen is that electrons within this jobber here are going to flow as far away as possible from that. So let's say they go down all the way here. But what that's going to do is it's going to leave behind positive charges. Okay, now conduction means I'm going to make contact. So contact, let's say I had those 4 protons there and the 4 electrons here. The electrons, once I make contact, are going to jump from my charged object that has excess electrons, and they're going to jump because they see 4 unbalanced protons. So they're going to jump onto that object, and they're going to try and balance out those 4 unbalanced protons, okay? Meaning that the charged object is going to give up some of its electrons. Okay, so it's going to give up some of its electrons to that. And then when I remove the object, okay, what's going to happen is I'm going to then have, protons don't move, but what's going to end up happening is I'm going to have 4 extra electrons I didn't have before, plus the 4 that I gained. So I'm going to have a total now, or unbalance, of 4 electrons based on what I have. So electrons move on to the object, making the thing now have an excess of electrons. Okay? So when we make contact, electrons are going to jump onto the object. Now, the only difference is that if this object was a positively charged object, then I would see electrons would jump onto the object itself once we make contact. Okay, so electrons are either going to flow toward or away depending on the overall charge. And again, we're going to look at both types. Next one, you have induction. So induction, think about the word induce. Induce means that you create a temporary charge, okay? So this one requires no contact at all. Now induction kind of makes use of polarization, but it's also going to make use of another type of charging we'll look at last called grounding. Okay, so induction is going to be when we bring an object near without making contact. So let's say that I bring a charged balloon near these conducting spheres. These spheres are originally neutral. Okay, when I bring a negatively charged object near, electrons are going to flow away as possible. Now, I notice I have two conductors here. So we're going to talk about this second conductor and what it is. Okay, but what happens, the electrons are going to flow as far away as possible. So now that I have a second conductor, they're going to move, originally polarization, they'd move to the outer edge. But now that there's a second conductor, it's going to jump all the way over here. Okay, then what I'm going to do is I'm going to separate these two objects. Now notice I never made contact with the negative balloon to that. There's always going to be some space between. I'm always going to keep it near. But when I remove them, those excess electrons that moved over now remain on B. So what ends up happening is B becomes a negative charge because the electrons flowed to it, and A remains a positive charge because those 5 electrons that left have 5 unbalanced protons. So what I've done is I've induced a charge on both of these objects just by bringing a balloon near. Same would be true in reverse if I had a positive balloon, but a positive balloon, the electrons wouldn't flow away, they'd flow towards, and the only difference is that the charge of these two would be opposite. Now, what's making use in these is we're using a process called grounding. So when I use those two spheres, the second sphere, B, was actually what's called a ground. A ground is a source of removing excess electrons or possibly giving electrons. Okay, so I kind of have the two here, that if, let's say, this thing has an abundance or excess of electrons, if I attach a ground to it, those excess electrons will flow out until everything is kind of balanced. And if I see an abundance of protons, meaning unchecked positives, electrons will actually flow into the object to make things balanced. This is things you see in like electric circuits and outlets. That third prong is called the ground prong because if there's any excess charge, whether it's negative or positive, that ground serves as a way to get those charges out of that outlet so that when you touch it, it doesn't give you a little bit of a shock. So this is called grounding. So there were, again, 5 types of charging: polarization, triboelectric effect, conduction, induction, and grounding. So we're going to go through a couple examples here real quick just to kind of show the difference, okay? So in this first one, I want to know, based on polarization, which of these diagrams would actually work. So polarization, again, is when we have the flow of electrons based on the charge that's given. So in this first example diagram A, I have a negative charge that's brought near. That's going to force electrons to move away from it, which I do see. So I know that A is a diagram that would end up working out. In B, again, I have a positive charge brought near, so that means electrons should flow towards the positive, but what I see is electrons are gathering towards the opposite end, so this one's actually opposite of what's going on, so this one would not work. In C, we see negatives and negatives, so again, they're gathering towards each other, which is not the case, not going to happen. And then in D, we see the positive charge looks very similar to B, but those electrons are gathering towards, so that one would actually work out. And then lastly, E, I have the positive charge here. I see electrons gathering. The only thing that's not shown is unchecked positives, but E actually does work out. Just know that in a regular situation, there would be some unchecked positives on this side because the electrons float away. So this is what's called polarization. All right, going into the triboelectric effect. Triboelectric effect has to deal with the type of material. So here's kind of a list of where these materials rank. So all the way on the bottom, these rabbit fur are things that are willing to give up electrons, and all the way in the top, Teflon, are things willing to take on electrons. So give up, take on. So this is kind of how the chart works. So here it says material A. We're going to try and figure out where it fits on this chart. So material A is rubbed with acrylic. So acrylic is right here, something that is willing to take on electrons based on where it is. It says A that A becomes negatively charged. It says A is then rubbed with cotton. Okay, so cotton's all the way over here, a little bit lower than acrylic, so that means cotton's willing to give up electrons, and it says once more, it becomes negatively charged. So where should A be placed on this series? So the thing is this, is that if A is willing to take on electrons, that means that acrylic and cotton are willing to give up electrons. So the way it works is that towards the bottom end, these are willing to give up, and these are willing to take on. So because A becomes negatively charged, we know that A should be somewhere above acrylic, meaning it's going to fall in one of those ranges. Okay, so it could be anywhere up from polyester all the way up to Teflon, based upon it wanting to take on electrons. Okay, next one we're looking at induction. So induction is when I bring a charged object near without making contact. So now we're going to go through kind of the steps together. So just to kind of show this, what I'm going to use is I'm going to use 4 electrons paired with 4 protons. Okay, I'm going to go through this kind of step by step. Now notice I'm bringing a positively charged balloon near. Okay, so the key thing here is that in this sphere, the protons are never going to move. So in all 3 of these diagrams, I'm going to draw my 4 protons. Protons don't move, so they're going to stay in the same spot. But what happens here is that when I bring a positively charged balloon near that metal conducting sphere, that the electrons, the 4 electrons, should gather towards that sphere. It's called polarization because if I were to cut this in half, notice the left side has an excess of electrons and the right side has a lack of electrons. So again, I'm going to keep that charged object near, and I'm going to see those 4 electrons gather. Now in step 2, if I cut that in half, notice that the right side of that sphere has 2 unchecked positives. So that means 2 electrons are going to flow in and going to try and balance out those 2 unchecked positives. In the end then, when I remove the ground and remove the charged object, I have again these 4 that are going to be balanced out, but then I have 2 excess electrons that are not going to be balanced out. I'm sorry, my pen's not working here, folks. Here we go. So I'm going to have 2 electrons unchecked. So here I'm going to have 6 electrons, and I'm only going to have 4 protons. So that means this thing is going to be an overall negative charge. Okay, so overall is going to be negative. That's called induction. And then lastly, conduction is where we're actually going to make contact. So it's going to start off the same way. Notice all of these are starting with polarization. So I'm going to use the same thing. I have 4 protons. Bring that positively charged balloon near. That means there's going to be 4 electrons gathering. That's called polarization because if I split in half, the left side is abundance of electrons or excess electrons. The right side has a lack thereof. Therefore, now when I make contact, and this is where it's going to be a little bit different. I'm still going to have those 4 protons. Those things are not going to move. But now that I make contact, okay, what's going to happen is that those electrons see that positive balloon and then they're like, oh yeah, I like that positive balloon. And what they want to do is they want to jump the gap. Okay, now that I make contact, they are allowed to jump the gap. So the electrons are going to flow onto the balloon, and let's just assume that all 4 of them do. Okay. They're going to flow onto the balloon, meaning now when I take away the balloon, all right, this sphere, all those electrons are now gone. They left the party. See you later. That means those 4 unchecked protons are still unchecked. So here, there's going to be 0 electrons left over. There's going to be 4 protons left over, meaning this thing is going to be an overall positive charge at the end. One thing you'll notice is that with conduction, they'll always take on the same charge that's brought near. And induction, they'll take on the opposite charge because of that grounding. Okay, so I know there's a lot of meat and potatoes here, so got any questions, drink it in, write them down, and then we'll look at these things in class. All right, baby shawties, peace out.